Hello, you're welcome to Skyline Tutorials, where learning is made simplified and understanding is better. In Skyline, we set a pace in every exam that any student or candidate would encounter. Welcome to Skyline 90 Days to JAMB tutorial for every science student. Nonetheless, this tutorial sets a platform and it is a recommended tool for secondary and tertiary level students in preparation for any terminal or semester exams respectively. Ladies and gentlemen, let the journey begin. Hello, you're welcome to day 3 of the Skyline 90 Days to JAMB. For today's class, we'll be considering measurement and units. The third content amongst the physics syllabus for this year's JAMB is that JAMBites are expected to understand the concept of measurement and units. So the objective of the class basically is to strictly look at physical quantities and units. So let's begin with the definition of a quantity. Simply put, a quantity is anything that is countable or measurable. Anything you can count or measure is referred to as a quantity. For example, I have speed. Speed is a quantity that is measurable. If I want to get the speed of a moving body or a moving object, you get that through the ratio of the body's distance all over the time. So if I'm asked to run a 100-meter race in relation to someone else, you get to realize that the distance 100-meter and the time it takes to complete that distance, let's say 50 seconds, is what will determine the speed of either of us. So speed is basically a quantity. Anything at all you can count or measure is referred to as a quantity. Other examples are length. You can measure the length of a body or an object. We also have mass as an example of a quantity. In physics, anything you can count or measure is termed a physical quantity more precisely. The next we should be looking at is the types of quantities. So let's look at the types. Broadly, there are two major types of quantities. We have the fundamental quantities, and then we have the derived quantities. Okay, fundamental. What does it mean for something to be fundamental? It means basic, basic. So fundamental quantities are basic quantities that are independent. Take for instance, a building. You get to realize that the foundation of a building is independent. On the other hand, every other part of the building depends on the foundation. Let's say the roof, the walls, and etc. So if the foundation of a building gets tampered with, the other parts are going to be damaged. It therefore means that the foundation of a building for this concept is referred to as a fundamental quantity because it is independent. On the other hand, every other part of the building that depends on the foundation of the building is derived. So derived quantities are referred to as dependent quantities. So for us to get a derived quantity, it is gotten by the combination of two or more physical quantities, either by multiplication or division. With that explanation, we can see here that obviously speed is a derived quantity. For speed to be gotten, it depends on other quantities, distance and time. So that's how you can get a quantity that is derived. And for fundamental quantities, broadly, there are three basic fundamental quantities, which are length, mass, and time. So if I want to get the length of this marker, for example, it is independent. It does not depend on anything. I just make use of an instrument to get the length, and it does not depend on any other quantity. That is why it is fundamental. Another example is mass. If I want to get the mass of this marker, it does not depend on any other quantity. As a matter of fact, mass is constant. So wherever this would weigh, it will be applied in every other place. So wherever I measure this, it is always constant. So since mass does not depend on any other quantity for its existence, it is referred to as a fundamental quantity. Another example is time. time is very, very fundamental. It is independent. As a matter of fact, almost everything depends on time. So these are the three basic fundamental quantities. However, there are others. But before we get to other types of fundamental quantities, let's list a few derived quantities and see why they are called derived quantities. Let's say work, for instance. Work done by a person or by a body. For work to be done, there must be things that will be in place for us to effectively do work. It therefore means work is derived. So, for example, I want to move this my marker this way. There are two things I must put in place for that to be effected. The first thing that must be applied to this marker is a force. Okay, so for me to do work, there must be an application of force. So let's say I want to carry a desk, I must apply force. Is that so? Yes. So work is dependent on force. It is not just dependent on force, because force alone is not what determines work done. For example, I can apply force to this board and I have not done work, but I am just applying force, right? I'm applying force right now, but I have not done work. Work depends on force and distance. So for you to effectively do work, the application of force must lead to a distance or a displacement. That is why it is a derived quantity, because for it to exist, there must be an input of force and a displacement of that body or object. There are 1001 examples of derived quantity. We also have force. Force is a derived quantity. It depends on mass and acceleration. The later part of this video will cover a table that denotes all the derived quantities that you ought to know as regarding the JAMB syllabus. So, ladies and gentlemen, we have successfully done justice with the definition of quantities and the types. We have said that a quantity is anything that can be counted or measured. Generally, there are two types of quantities. We have the fundamental quantity and the derived quantities. Fundamental quantities are independent quantities. They stand on their own. They do not need any other quantities for it to exist. However, derived quantities are quantities that are dependent. For there to exist or for it to exist, there must be other quantities that it depends on, either by a multiplication or a division, like we have a few examples here. The next we'll be considering is units. So the next objective of this class is for us to understand the concept of units. Unit is basically a universal or standard way of measurement. It is a universal or standard way of measurement. For something to be standard means it is generally accepted. It is generally accepted. So unit gives the standard of every measurement. For example, we would use time. Time has different variables through which you can measure it. You can measure time in days, you can measure time in weeks, you can measure time in months, in years, in decades, in centuries, in seconds, in minutes. But there is a universally accepted unit for measuring time, and that is seconds. So if you go anywhere in the world, you get to see that seconds is the unit for time. That is why there's an essence for the word unit, because it gives a standard or universal accepted measurement to everywhere in the world. Another example of units, let's say the unit of length is meter. You can measure length in centimeter, in decimeter, in millimeter, but there is a standard, and the standard is meter. Another example is mass. You can measure mass in grams, in pounds, in kilograms, but the universally accepted is kilograms. Ladies and gentlemen, that is the essence of units. It gives standard measurement to every quantity. For example, I go to the market, I can measure, let's say I want to get rice. There are different means through which I can get my rice. I can get my rice in bags, in models, in cups, but the most common, and we can agree that, though not scientifically proven, that we can say cups is the unit of rise, okay, because that's the most common and accepted, though it is not scientifically proven, just an instance. So it is the same thing that's applied here. There are different ways of measuring quantities, but the universal and generally accepted method is what we refer to as a unit. Okay, so basically these are the units for the three most important fundamental quantities. Let's mention the others that you ought to know. Another fundamental quantity is temperature. The unit for temperature is Kelvin. Another fundamental quantity and its unit is amount of substance. Amount of substance. Amount of substance is measured in moles. Another example is luminous intensity. Luminous intensity. It is measured in candela. Another example is electric current. Electric current is measured in ampere. So these basically are all of the fundamental quantities that you ought to know as regarding your JAMB physics. So we have time, length, mass, temperature, amount of substance, luminous intensity, and electric current. And these are the respective units. So that is it for fundamental quantities and fundamental units. The next we'll dive into is the table that represents majority of the derived quantities, their derivation, and the units. Okay, so let's list out the most common quantities that are derived, their derivation, and the units. The first we'll be looking at is area. Area basically is the total distance around the shape, or yes, a shape or a building. Let's say I want to get the area of this room, for example. It is gotten by the multiplication of its length and its breadth. So since it depends on length and breadth, it is a derived quantity. Remember, derived quantities are quantities that are dependent. For them to exist, there must be two or more other quantities that must be present. So if I want to get the area of a shape or whatever, it is calculated by multiplying the length times the breadth. Since length is measured in meter and breadth is measured in meter, meter times meter will give us meter square. So that becomes the unit for area. Another example is volume. Volume is measured by multiplying the length times the breadth times the height of the shape. These three parameters are measured in meters. Length, breadth, and height are all measured in meters. So m times m will give us m cubed. So that makes it the unit for volume. Another example is speed. Speed of a body or an object is calculated by the ratio of distance and time. So for us to get the speed, we divide by the distance and time of that body. So the unit of distance is meter and the unit of time is seconds, making meter over second the unit of speed. Another example is velocity. Velocity is gotten by the division of displacement of a body all over the time. There are some basic similarities between velocity and speed. They both measure distance over time. But the disparity is that velocity is to a specific direction. So whenever there is a directive or a direction property to a question, it is velocity instead of speed. For example, I can budget a vehicle moving to the north. Whenever there's a specific direction to every question, it becomes velocity. But I can just enter a vehicle that's moving at a particular speed, but there's no direction property. So that's basically the difference. Speed is just distance over time with no direction, but velocity has direction. But they are both measured in meter per second because displacement is to meter and time is to seconds. Another example is acceleration. So the acceleration of a body is the velocity over the time taken. So The unit is meter per second squared. Another example is force. Force is gotten by the multiplication of mass times acceleration. Mind you, most of all of these quantities are treated as a topic on its own. Like when we get to the concept of force, they will be treated independently on its own. So what you should majorly understand here is basically the derivation of the force and why it is a derived quantity. So for us to get force, I multiply mass and acceleration. This acceleration could be linear acceleration or acceleration due to gravity. The unit for force is Newton, Isaac Newton. Okay, so you can as well get another unit through the units for mass and acceleration. So this is all. Unit for mass is kg and unit for acceleration is meter per second squared. So another derived quantity we have is work done or energy. To get the work done, you multiply force and distance. So the product of force and distance gives the work done. Like I said, for work to be done, there must be an application of force, not just that a distance must be made. So the unit for work done or energy is joules. You can also get the unit from the combination of these two quantities, which is Newton for force and meter for distance. Take notes of that. Other quantities are power, which is gotten by the ratio of work done all over time. So work done is measured in joules and time is measured in seconds. So either joules per second or Mr. Watts is the unit for power. Another example is density. The density of a body is gotten by the ratio of mass to volume. So density is mass over volume. So the unit for mass is kilogram and the unit for volume is meter cube. I hope you are following. The next quantity to be looked at is impulse. Impulse. Impulse is simply force times time. Force is measured in Newton, time is measured in second, making Newton second the unit for impulse. Another example is momentum. Momentum. Momentum is simply mass times velocity. So the product of a body's mass and its velocity will give us the momentum of that body. Mass is measured in kilogram, velocity is measured in meter per second per second. So that makes kilogram meter per second the unit for momentum. Measurement basically is the process of quantifying a quantity. Okay, so the process of taking the amount or quantity of something is measurement. Okay, so when we are taking the measurement or derivation of all of these is what we refer to as measurement. Take note, it is comparing a physical quantity to its unit, a physical quantity to its unit. That's what the concept of measurement is about. Subsequently, in other episodes, we'll look at some measuring instruments. We'll also look at the dimensions of all of these physical quantities. So for this series or for this episode, we have been able to cover physical quantities, their types, units, their types, and examples of all of these. I hope you found this class interesting. Questions on this concept will be reviewed subsequently. Ladies and gentlemen, we have come to the end of this episode.